Folks, welcome back to the shop. Frank here, working on the Cub Cadet 4x4 articulating tractor. Last week I revealed that there were some issues that needed to be addressed. I split the tractor, basically replaced most of the drive shaft. So got a couple other things to do to get the machine working again. Going to look at installing the hydro control plates. What the hydro control plates are, here's one of them. This is how the hydrostat is controlled in the normal tractor. And there's a reason they use this, is because a relatively long movement here, 3 or 4 inches, results in just a small movement through this cam of a pin that this slot operates. So what it does is it gives you finer control of the hydrostats compared to what I currently have. What I currently have is a direct, 2 or 3 inch, 2 inch movement. This gives you about a 4-inch movement. So I think I'm going to put these back on. I should be able to operate these the same way with the dash lever and the flexible shaft, the push-pull shaft. The other thing this does is give you a neutral return. You pull on this and it brings the hydrostats into neutral, and then there's an adjustment using this bracket bolted to the hydrostat. Since the hydrostats are turned around backwards, I don't know how I'm going to use this yet. I haven't figured that out, the neutral return. It would be nice to have. Maybe able to do it with another flexible shaft to get it on there and play with it and see how it works. But in any case, I'm going to try to put these control plates back on, both hydrostats. Give me better, more finesse in the control of the speed of the tractor. Won't be as jerky, won't be as sensitive to movements of the lever. So this is not really rework, this is an improvement. And there's one other improvement I've thought about, but I haven't started working on, that's brakes. And I think I'm going to have to go to hydraulic brakes. There are disc brakes on all 4 wheels. So, and I have the disc brake pads. It's just a matter of putting them back on the axles and rigging up cylinders to operate them, and a pedal, master cylinders, slave cylinders system to do that. And I think that's going to be interesting, not too difficult to do, I don't think. So first thing I'm going to do is see about fitting these control plates. The things I need to do are get the flexible shaft hooked back up to the hydrostats so that I can control them, but they'll hook to these plates instead of what they're hooked to now. Then it's reinstalling the seat and we should be good to go. So this is the control plate. This is, I think that's right, and this is the cam plate. So I'm going to get this pin in this slot and the bracket under these 2 washers. The washer there. There we go. Get the other bolt in. That doesn't help you any. Forgive my hand there. All right, so moving this plate up and down gives you a neutral adjust, or is your ability to adjust your neutral. All right. So you can see that the movement here to here is much greater than, it's probably twice what the movement that you're seeing on this part. I'll give you a better view. All right, so the way this works is, of course, this slot is on a pin on the control plate. And by moving this cam plate, the neutral keeps pulling it. All right, so this point here moves probably 4 inches, where this one only moves about 2 inches. So it gives you much finer control. Now, there's a little bit of play in that at each point, not too much. So in terms of the accuracy of the control, it depends on how worn this slot is. This slot's not worn much at all, so I think we're in good shape here. So instead of moving this, we'll move this. Probably have to put an extension on it or something to reach the cable. We'll see how long the cable is. It may be fine because for the front one it'll be set back as well. So, all right. That explains the use of the cam plate, moving the control plate. I may have called this a control plate, but I think that's incorrect. I think it's a cam plate.
That's easy. That's 3/4 of an inch thick. Pretty tough to get through. Maybe could have sawn it the whole way, but eventually that worked. So that makes room, I hope, enough room for the control plate. Yeah, so that's we had to cut out. That's the angle iron that was underneath it. And I think the torch did reasonably well till it got to cutting parallel to this edge here. But anyway, the plasma torch did okay for, it's only rated for 1/2 inch material, that's 3/4. It's only 45 amps. I will tell you that usually there's a lot of slop in this plate joint pivot. This one doesn't have any. I don't know whether the other one was really close too, didn't have much play. So that indicates that either not much wear on these, which for their age seems unlikely, but all right, that's going to give us plenty of room. Get my little electric ratchet here. Who's that I hear coming? Huh? Is that Butchie or is that Brew Brew? Who do I have here? Oh, got both of them. Oh, my good, here, come here. Come here. Come here. Yeah. You being good boys. You being my good boys. Yeah. Okay. Good boys. It doesn't have to be perfect. It looks pretty good. Pretty close. My card filled up, data card filled up, and the camera cut off. All right, so this is the arm that'll come off the control shaft that'll hold the front of the linkage rod that goes back to the cam plate. This is just a 1/2 inch roughing mill. Alright, so that be high enough to connect to this point and give me enough motion. Now I drilled like 4 holes in here just so I would have some play. Alright, so I need to make this longer. Alright, so I need to thread the end of a piece of 5/16 round stock to make a longer
connecting link between the dash lever, the bottom of the dash lever, and the first hydrostat. So I've got a piece of 5/16. This is actually this is from a leftover part from that I cut off. So got this. This I think is about the right length. I've got a couple of connecting links for the end of it. I'm going to use my tailstock threading die holder. If you haven't seen this in use, I'll post a couple of links here to the videos where I made this. It was a kit from England, so pretty interesting. Anyway, it's got the 5/16 die in it, mounted in the tailstock, and mount this rod in the headstock, and we'll turn the threads on the end here. All right, so the die holder takes two different size dies, 1 inch, and then also takes the 1 inch hex dies, a little different diameter. Some set screws in here to hold the dies in place. Anyway, then there's this Morse taper, fits in the other end, fits either way, depending on which die you want to use, which one you want to use. And of course it has a clearance hole in it for the working part to go into. We've got the 5/16. Now the rod ends I have are both right hand threaded, so I'm going to do a right hand thread. The original one, the shaft I'm working with, had a right hand thread on one end and a left hand thread on the other. I want to use new rod ends. I have new rod ends. They're both right hand threaded, so that's what I'm going to do. Okay. Let's see if the chuck can even grip this. And just barely. Okay. Well. All right, almost have to go to a collet or something, but it looks like that's going to work. Okay. Using this lever, there's a clutch built into this device. Use this lever, push it forward, engages the clutch and pushes the die onto the threading, the part, the workpiece, and it slides on the Morse taper adapter. So this whole unit will slide forward on the Morse taper adapter over the shaft. We'll thread it about 1 inch. See, so if I center it, then there's no clutch action. It doesn't engage. And then of course we go backwards. Push it the other direction, and it unscrews. Now you can see it's a little off kilter here. Because the shaft is not perfectly straight. It's actually, it looks like a little undersized here. Yeah, I'm going to say, I don't like that. The threads are not complete. Let's get another piece of stock. All right, I cut a new piece of stock the same length, and I mean, you can tell it's a different diameter. It looks like the end of this is
has a larger diameter than the shaft. I don't know whether that's from corrosion or what, but in any case, this is basically the same length, new piece of 5/16 stock. All right, so in the middle position like this, the clutch and the cutter is not engaged. All right, let's reverse the rotation. All right, so makes a nice thread there, okay. The clutch inside here is very effective. It's got, it's two cones, opposing cones that mesh together depending on which way you push the lever. All right, we're going to go backwards now. Okay, that's a much better looking thread. This is 5/16 24. Yeah, these are the new rod ends I have. I think in a previous video I called them a Heim joint, but they're clearly not a Heim joint. That's like a little swivel eye kind of thing. They're just rod end connectors or something. All right, so that's one. All right, and this is the other one. All right, so that's our new connector. Let's go fit it, see how it works. All right, after much fiddling around and playing with the brackets and stuff, I finally got it to the point where you can compress the spring here, which you want to be able to do at the forward, and then basically have it fully extended in the rear direction. So it took, you know, a couple different tries. You know, you can't put this rod end in here when you're moving in this plane. It needs to be horizontal. And here it needs to be vertical because that's the plane it's rotating in. So something to think about so that you have, you know, adequate clearance. All right, so I've got this. It gives a lot more control, movement for, you know, the same movement I had. Before I only had like, you know, a couple inches. Now I've got like 10 inches, quarter of a turn, basically, what this is. So much more finesse on the control, speed control. Now I need to... So I've been using this. The more I use it, the more I like it. I mean, it's M12, so it's limited, but it's great for deburring because these inside edges, it's hard to get on the belt sander or the disc sander. So far, I'm happy with it. I got it at Napa. They gave me a free battery with it. So anyway, it's a neat little tool. All right, this will be the bracket for the front control cable. There's my butchie boy. Where's your brother, huh? You're such a good boy. You've been out in the rain this morning? Yeah, been out in the rain. Oh. Where's Brew Brew? Where'd Brew Brew go? All right, I'm in the process of reestablishing my stationary points for the flex shaft to control the two cam plates. So I'll bring you back when I have a little more progress, taking some fiddling around here. Oh, there comes Brew Brew. Oh, what a good boy. What a good boy. What a good boy. Come here. Come here. Yeah. Oh, what a good boy. Oh, you're not so wet. Where have you been? You been underneath the porch or something? Huh? Yeah. My good boy. My good boy. I'm about done. I have been working now all day on creating the attachment points and trying to synchronize. Can't fully synchronize until we run it, but at least partially get it close. So if you do this, there's some factors you need to take into account. You need to make sure that where you make your connection point, like this one, it has to be the same distance from the pivot, same radius as the other one, right? So if you're not careful and you don't get these pivot points at the same distance, same radius and distance, same radius, distance, then the two cam plates won't move in unison. If one of these connection points is closer to the pivot point, then a given amount of motion, 2 inches say, will move this 45 degrees, but if the other one's further away, it may only move 40 degrees or 35 degrees. So you may have them synced at one point, but they'll be out of sync at any other point in the travel. So you need to be careful about that. Now up here on the front, you're just moving one, you're not synchronized with anything, you just want to achieve full travel of the swash plate and of the control plate and the swash plate. So it's important that you get to the point where the springs start to compress at the front and at the rear. If you have to sacrifice one or the other, you sacrifice a little bit at the rear. I mean, you can sacrifice some speed at the front too. It's 8 miles an hour and 5 miles an hour. So that's the speed of these tractors roughly. So I think I've got here, I'm on the spring at that point and on the spring at that point. So now I will jack the tractor up and check it all out. I did have to make a new support point here for the flexible shaft. I modified, changed the location of the rear one. So balancing the length of the flexible shaft is important. Obviously the distance between the two connection points and the travel at each end needs to be pretty close to the same. So, but like I've said before, synchronizing the hydrostats is not an exact science. There is some, what did I call it before, ambiguity in the hydrostats output for any given input rotational speed, because it is not a solid geared connection, it's a fluid connection, right? So, the hydrostat, there's a hydraulic pump and then there's a hydraulic motor. And the engine turns the hydraulic pump, that fluid flows, drives a hydraulic motor, which creates the output. And that then goes into the transmission and drives the transmission through a reduction gear. And again, you got the same thing on the other one, but the second one is driven the same speed as the first one by the engine, because the top pump shaft goes all the way through the hydrostat, comes out the back, goes into the next hydrostat. So that's engine RPM 3600 max, roughly. And of course the output is reduced significantly. There's a reduction gear in the transmission, the front of the transaxle, or in this case, most cases, in this case, the rear of the transaxle. But that's neither here nor there. Okay, so I'm done here. This has been a little bit of an ordeal. I've been here, this is 3 days of work since I replaced the drive shaft. I'm sorry, 2 full days of work. All day yesterday, all day today. It's 2:30. I was out here at 9 o'clock. I did take a half-hour break for lunch. So I think I'm at the point now where I'm ready to jack the tractor up and synchronize the hydrostats. So we'll come back next time doing that. We'll synchronize the hydrostats and put the seat back on it and take it for a drive. Test everything out. Keep our fingers crossed. All right, folks, that's going to wrap up this episode. Learned a couple things in the process here of reworking the tractor. As I said in the last episode, it wasn't something I was looking forward to, but it became pretty clear during the first two test drives that I was having issues with the CV joint and the speed control was just too sensitive. So I think I've got those two things fixed. Your universal joint's not the perfect thing. You really would have been much better to use a CV joint. It's just that this application at the speed, don't think it's practical or even possible. I don't know. I looked, some of you guys know, if there is a CV joint that will run at 3,600 RPM, please put it in the comments. I looked for quite a while trying to find specs on CV joints in terms of maximum speed and that kind of. I couldn't find anything. I did find high-speed CV joints, but they were all for automobile applications. So, that's still under 1,000 RPM. So I don't know. If you do know and there's CV joints someplace that can be used, then I would love to hear about it. I looked into McMaster and there's nothing there, hoping that they would have some kind of special CV joints, but they don't really have any CV joints. You type in CV joints and you get universal joints. So that's where these universal joints came from, McMaster. So they're good quality universal joints. I'm hoping they'll stand up. Now, one of the forgiving factors about this driveline, even though it's high speed, is that it is relatively low torque. I mean, it's engine torque. I mean, we're only talking 12, 13, what's this, 14 horsepower. So that's not that much. Especially at this high speed, it's relatively low torque. Since I brought the tractor in and split it, it's been five solid days of work, and I'm talking 6 or 7 hours a day out here in the shop, doing the 3 days for the drive shaft replacement, 2 days here for linking up the hydrostats and changing the speed control. That's where I am right now. As I said, we'll come back next week, jack the tractor up, run the engine, adjust the linkage between the two hydrostats as best we can to synchronize them, and get the seat back on it, and hopefully we'll take it out for a spin. This time, I'm hoping it will perform and handle better. I'm down to one steering cylinder, and there is something that happened during the last test drive that I haven't mentioned, and some of you may have noticed it, is that I couldn't fully turn to the right. And, at first it just kind of baffled me. I didn't understand. Well, I had left the right side steering cylinder on the tractor and just mistakenly or naively connected the two ports together just so the fluid wouldn't fly out all over the place and I wouldn't suck any dirt into the cylinders, thinking that the fluid would just go back and forth between both sides. It doesn't work that way. One side of the piston, one side of the cylinder, the piston side, has bigger volume than the rod side of the piston. So anyway, there's not enough room on the rod side of the piston to take all the fluid that's on the piston side. And of course, the rod side of the piston is what gets compressed when you turn to the right. So anyway, it didn't work so well, but I've taken that off and down to one cylinder. I think there's plenty of power for that. Anyway, just a lesson learned. You can't jump a piston. You can't jump a hydraulic cylinder from one side to the other and operate it without more than a certain amount, depending on where you start. So if you start with a
empty rod side, you might be able to move it halfway or something, depending on the size of the cylinder and the size of the rod, obviously. The difference in the volume between the two sides. I guess if the cylinder is in the position where the rod is completely in, so the amount of fluid you have is what's on the rod side, you can move all that to the piston side and back. So that would be the situation that you would want to do it. If you have to do that, make sure the rod is all the way in so that the volume of fluid is at the minimum, which would be the rod side full. And in which case, when you move it, there's room on the piston side for all of that fluid. I had it somewhere in between, halfway. So halfway is not enough room for the fluid to move. Not enough room for the fluid to move. Okay. I think I'm done. Thank you for watching. We'll see you next week.